Hey everyone, Malik here, and super excited to be joined by Dr. Alok Patel. If you don't know, he is super cool. I think at Alok Patel on MD on Instagram and the socials. Super cool, and I feel like you make learning about medicine really fun. Learning about the vaccine, super Gen Z. I feel like that's hard to imagine making all this fun, but you managed to do it. What are you doing on a daily basis? I feel like we just got to talk a little bit. You're doing clinical stuff? Are you in the hospital? What's going on with you? Because I feel like you do a ton of interviews, but also you're like a practicing doctor.
Hey, Malik. I don't know how to follow up that grandiose intro. I mean, I hope that I hope my antics online come across as fun because that is the point. But, thank you for having me on. It is a pleasure to be with you. And I'm going to tell everyone out there that I really dig your flat top. And I think you're bringing back the early 90s in a very crisp, fresh way. So you nailed it on the head. I work in journalism and I work in science communication, if you will. Sometimes that means hopping on the news. Sometimes that means writing articles. I also host a podcast, but then I still am working in the hospital. So I'm a pediatric hospitalist, which means I only take care of children. Excuse me. I don't have coronavirus, I promise. But I take care of kids who are hospitalized. And so the past year has been really interesting. Children's hospitals are commonly really busy, but now we've gotten this extra influx from coronavirus happening in other hospitals in the community. There's been changes happening all along. All of us have been on high alert. It's just a very crazy time for medicine, which I'm sure everyone out there has seen on the headlines.
A few moments later.
But I'm doing dry January for coffee and chai, so I'm barely surviving. But yeah.
All right, so we're still recording, right?
Yeah.
So I'm proud of you for doing dry January. My dry January literally ended on January 1st at like 12:30 a.m. It's not gonna happen.
I love
this is not an appropriate health message, but if you look behind me, the cocktail mixology habit is real.
Oh my gosh. Oh
it's
my,
real. It's real.
I would think if you did not show me that, I would have thought there were all like PhD author written books.
I mean, there's PhDs I could bond with over here with making some old fashioned cocktails, but hey, we're not going to talk about that right now.
No, not at all.
Anyway, back to the pandemic, Malik.
Yes, back to that. I have to make news. That's what we're supposed to do. You just got your second dose of the vaccine, so this is like breaking news. Super. What do they call it? Fast developing. Or so there's another word I'm thinking of. This just in. So how are you feeling? I've heard soreness is the biggest effect.
Yeah. So it is late breaking news. The development, if you will, is my immune system building up antibodies against the virus, which is phenomenal. It was a great feeling. And it's not because part of it is me getting the vaccine and feeling protected and feeling like, wow, I'm more protected against getting a symptomatic infection. But other thing is it feels like a huge victory for science. This has been an unprecedented global collaboration to get this vaccine developed out there in a safe and effective fashion. And it kicks ass for lack of a better word. Now, how I'm feeling after the first Pfizer vaccine. So I got the Pfizer one, there's Pfizer and Moderna right now in the United States. I got the Pfizer one on December 23rd. I had a little bit of arm soreness, but it was fine. It went away after a few hours. And the following day, so about 24 hours after, I had a little bit of a headache and I needed to take a nap, which I never take naps. So I was like, oh, a little fatigue. This shot, I just got this. Today is the 14th. I got this the morning of the 12th. At around the 8-hour mark, I had a headache. I was a little bit fatigued. And then that night I had chills. I had rigors. It means I was kind of shaking. Didn't really feel that great. I didn't sleep very well. But here is the really important thing. I was rest assured because that was my immune system actually working. Now, someone out there might say like, oh my God, that's an adverse side effect. And I wish adverse side effect got a different PR agent and rebranded itself because it's not adverse. An adverse side effect is a side effect that you don't expect. So it's something that is like, whoa, that shouldn't happen. That's adverse. What we're all experiencing from the second vaccine, I say we and a lot of people who have fatigue, headache, muscle pains, is called vaccine reactogenicity. It's a $10 word. But basically, that's your immune system revving up and saying like, okay, I got a vaccine. I need to build something off of this blueprint. And while that's happening, you get the muscle soreness, you get the headache, you get a little bit of possibly a fever, things like that. And it's all good. I feel great now.
That is awesome. I mean, thank you for being transparent, because I feel like people want to hear like what's going to happen and what might happen to them. And I think the fact that you went back, you didn't stop after your first dose, you followed all the way through, and now you seem great. So that's good.
Well, okay. And, so I think that's really important. What you just said there is we have to be transparent about expectations, because we need people to know that 99.99% of what they feel after the vaccine, if they feel anything, is expected and normal and will pass.
Cool. So a lot of young people right now, I feel like there are probably some young people that like wish they could just like stick it in me right now so that life can get back to normal. When will young people be able to get the vaccine?
I wish I had a crystal ball to tell you. I respect every young person out there who's asking this question, because young people, and we're all young at heart, but when I say young people, I legitimately mean like Generation Z, like those 16, to call it early 30s, that age group are going to be key to getting us back to herd immunity, to making sure that we finally beat the pandemic. And as it looks right now, that group is probably going to be towards the end of these phases, which are being rolled out. Now, when I say towards the end, I don't know if that means March or if that means May. I would guess right now, I would make an educated guess that it's going to be sooner rather than later, because we're starting to ramp up the supply of vaccines. Now, any young people out there who are studying supply chain management, which I didn't study, you know that actually getting the product created is only half the battle. You actually have to get the product into people's hands. So we rev up the vaccine supply. We need to make sure needles actually go into arms. This process, if it becomes really efficient, if the United States gets great at it and starts vaccinating more than 1 million people a day, I could see young people being moved up faster in the line. And the government saying like, okay, guess what? Mass vaccination campaign, we're going to convert concert halls and fairgrounds and stadiums into places where anyone can go and get shots. I could see that happening sooner rather than later.
Wow. Yeah.
So be ready for it.
That's crazy. I mean, it's all happening so fast. And I think that, 1 million people a day sounds crazy, but maybe we can do it. And that might be some of the reason for some of the concern too about the vaccine. We heard the word warp speed like 1 million times as we got to this point. Was it rushed, or were they genuinely able to come up with a safe vaccine this quickly?
This is like the question. This is the most asked question, the biggest source of misinformation that I personally have heard, and I'm glad you're bringing it up. First of all, Operation Warp Speed, probably not a good name, because it already kind of lays doubt into the process. Now, the reason why people feel it was rushed is because we focused so much on the speed. That was every headline was like, breaking speed to develop a vaccine. This vaccine's been developed faster than any vaccine in history. And it's true. The average vaccine took about 10 to 15 years, maybe longer to develop. The mumps vaccine, 4 years. And so obviously this being developed in under a year, you're like, whoa, they had to have skipped some steps. Here is why no safety steps were actually skipped. What people need to understand out there, Moderna and Pfizer is based on an mRNA vaccine. So mRNA is essentially a blueprint that teaches your cells how to make one of those spike proteins on the outside of the coronavirus virus itself. And that's what you make antibodies against. That's what your immune system fights. These types of vaccines have been in development since the late 90s. The first idea was in the early 90s. So they've been around for a while. So basically what happened in January is these scientists out there were like, hey, we know how to make an mRNA vaccine. Just give us the genetic code. And so when coronavirus started to break out in China, the genetic code was passed within a week. So right away, boom, scientists were able to start working on an mRNA vaccine with that genetic code. And we have never seen, ever, a global, transparent collaboration towards a singular scientific vaccine goal. Like unprecedented. So you have all these scientists working together. On top of that, this was pre-existing technology. On top of that, we had a ton of funding. And so you put all these together and you can tell why the actual process of creating it and the science was able to move really quickly. But what people need to understand is that the same phases of clinical trials were undertaken. So phase 1, 2, and 3, those phases, which basically check to see if the vaccine works, if it's safe, what the dose is, who should be getting it, no steps were skipped there. And so you already have all this data now done. And then you have an independent review board. That's the Vaccines and Related Biological Advisory Committee. Independent review. They've got no like financial interest in this at all. They review all the data. The CDC reviews the data. The FDA reviews the data. And then other groups from around the world also review the data. So you put it all together. And that's how the vaccine was able to get made so quickly. And then with all the groups looking at it, that's how people can be assured that the process, even though it was rushed, no safety checks or efficiency checks were skipped.
Yeah,
that was a long answer.
Yeah, no, but I didn't know about, just the mRNA and just like getting the gene and the process of it. So I feel like that's super good to hear. And then that phrase that we heard for all of us that were just sort of stuck at home, we're in this together. You guys were in it together too in the medical community, which is interesting to know. And that sort of makes sense that if everyone's working on this together, there's more money, that there's going to be a little bit of speed added into it.
Dude, when people were saying to me, they're like, oh, but the polio vaccine took so long to be made. How could you rush this? And I'm like, do you think science has progressed in 70 years? It's hard to compare science from previous decades because technology and innovation advances. It's like someone saying like, how can we have internet? They didn't have internet in the 40s. And I'm like, congratulations.
It is now 2021. So speaking of like the vaccine, my mom is like, I don't know if you should get this because you have some allergies. And I know that's been a big concern. Who should be saying, I really should take a step back and maybe not get it?
So I respect your mom for looking out for your best interests and asking the right questions, because a lot of people out there have been asking if the vaccine is safe for them if they have allergies. And I'm not saying blame, those are fighting words. I blame some of the media headlines, which have kind of added fear to people because of fear of anaphylaxis. And anaphylaxis is a severe allergic reaction to something. Could be latex, peanuts, an antibiotic. And in this case, people are worried about anaphylaxis to a vaccine. So as of right now, the only people who should ask their doctor or ask their healthcare provider if the vaccine is safe for them are people who have a history of anaphylaxis or a severe allergic reaction to a previous vaccine or a specific vaccine ingredient. So in other words, if you have really bad allergies to anything else, you're still safe to get this vaccine. If you have specifically a bad allergy to vaccines, chat with your doctor, but odds are you can still get it. So here's the facts laid out. Before the coronavirus vaccine was out, the CDC estimated that anaphylaxis occurred about 1.4 per 1 million doses of vaccines. So very, very, very rare. And so far with the COVID vaccine, there was a report the CDC put out last week. I think it was January 6th-ish. And we had estimated that we have about 11 reported cases of anaphylaxis per million doses. That is extremely rare. And that's why after you get the vaccine, people are hanging out at these medical facilities for 15 minutes because anaphylaxis or a severe reaction will more than likely occur shortly after you get the shot. So where I got the shot, they have vaccinated thousands and thousands of people. They've only had 2 bad reactions, and neither one of them was anaphylaxis. They were just mild reactions. So a lot of fear out there, but just take a step back, take a deep breath, chat with your doctor, and the overwhelming majority, remember, 1 in a million, people are going to be totally fine. The odds of an asteroid hitting the Earth, by the way, is about 1 in 150,000. So everyone needs to chill.
I love that. Take a chill pill, especially because that's a good statistic compared to the other one that you shared. So about the long-term effects of the vaccine, right? I feel like we don't know. There's still more to learn, at least about COVID even. And I'm sure about in 10 years, what does COVID do to a person? What does a vaccine do to a person? What is your message to those who are concerned about the long-term effects?
That's a great question. So the message I would tell people about the long-term effects is to not worry about them. And here's why. So the science used to make the COVID vaccine using an mRNA, there was some mystery about that. When you read blogs online, people are saying, oh my God, what does this actually do? Is it going to mess with my genetic material? mRNA does not change your DNA. And so it's not going to go into your cells. It's not going to hack and rewire or reprogram your genetic code. That's not what it does. mRNA is literally just a blueprint to make a protein. I got to say this though, because people are out there worried about this.
No, I'm laughing because it's so real that so many people have said, you might, I've heard literally you might grow an arm or like, and I think people are like genuinely a little like, even though these are crazy ideas, I think people are concerned.
It's not going to, that's not what happens. It's like if I were to put a blueprint to build a car in your garage, it's not going to go backwards and change your previous cars you have there. It's going to show you how to make a new one. So people just need to realize that the science itself is very safe and it's been around for a while. Now, with regards to long-term effects we don't know about, remember, all your body is doing is revving up to defend against this one specific spike protein. That's it. And the spike protein is found on the coronavirus. So the vaccine is not going to get your body to harm other parts of your organs. That's not how it works. And then another thing people need to realize as well is the actual virus itself. The effects of the actual virus are a little bit more widespread. And when people say like, oh my God, coronavirus caused all these problems in people, how is a vaccine not going to cause that? Remember, because coronavirus itself is going to replicate all of your body. There's receptors for the virus on many different organs. And the immune response to that virus running wild is what puts people in the hospital. And that does not happen with the vaccine. The vaccine is not the live virus. The vaccine cannot give you COVID-19. The spike protein blueprint we keep talking about is not going to go backwards and find a way to harm your body. It's basically putting a wanted poster in your body and saying like, if you see this suspect, take his ass out.
I love that analogy.
The last thing I'll add really quickly is the majority, if not all, of really adverse reactions to vaccines throughout history are going to happen, if not really quickly, like we talked about with anaphylaxis, usually in that 6 to 7 to 8 week window. And when I say adverse reactions, if there was something with people feeling ill or, anything else that scientists would worry about, you catch it in that early window. And the first people who got the COVID vaccine now, it's several months away because these trials have been going on since the beginning of 2020. I'm sorry, not the beginning of 2020, the middle of 2020.
Yeah. So last two questions here. What do you, for everyone who's saying, I had COVID already, like, why do I need a vaccine? If I've already had COVID, how do I know the antibodies of the vaccine will last longer than the antibodies from having it?
That question also, these are great questions, young people. Proud, I'm really proud. So I briefly mentioned earlier that the actual infection from SARS-CoV-2, the virus which causes COVID-19, infects people in a huge spectrum, right? So some people get it and they're asymptomatic. Some people get it, it's like having a common cold. Other people wind up intubated, a breathing tube down their throat or worse. And the reason why that happens is because it affects a lot of people differently. And after that, your immune response could be different. My point is that we don't have a consistent way to tell people, hey, you got COVID-19, so you have X amount of antibodies, or you have this level of protection. We do know that getting infected with COVID-19 will offer some natural immunity and some antibody protection, but it's not controlled. And the proof of that is people have gotten COVID-19 more than one time. With respect to the vaccines, these vaccines were developed to make sure that people get a consistent level of protection. And they're basically programmed so that we know that every person who gets this vaccine is going to get 94 to 95% protection from a severe COVID-19 infection. So in other words, we're dealing with natural immunity over here. We could have really bad side effects. People can die from it. You also don't know what level of protection you're going to have. Whereas a vaccine, we already talked about how it's safe and we know it works, but we're going to give people a consistent level of protection. And what this is going to lead to, the vaccine arm, is to herd immunity. And in a really quick nutshell, what that basically means is when we get more than 70% of the people in this country vaccinated, we then know what level of protection these people have against themselves. But we also know that SARS-CoV-2 can't really bounce around from person to person because people are all protected against it. When that happens, pandemic's over.
And on that note, what does this ending look like in terms of, do we then phase, like, I feel like people think there might be one day where like July 2nd, we just wake up and no more masks and everything's over?
So I think it'll be a transition. It's going to be a slower transition. We're not going to wake up one morning and say, everyone go outside, take your masks off and kiss each other. I think it's going to be a progression. We're going to have to track to see how many people have gotten their vaccines first and foremost. That process is going to take us from a month ago until probably the end of summer, early fall, if you look at how many people are getting vaccinated a day and how many more we need to get vaccinated. So I said, more than 70%. How many people are in America? Like 380 million. So 70% of that. So you're talking high 200 millions of people need to get vaccinated. We've only vaccinated about 10 million. So we have a ways to go before we get there. And then we'll start, as that's happening, I'm sure we're going to be looking at outbreaks, what cases look like throughout the country, what hospitalizations look like, and look to see that trend as well. Right now, we are failing badly. We're having over 100,000 hospitalizations each day. We're on day number like 40 of that. And so I'm sure scientists will be tracking all these different curves. And then sooner or later, we'll get to a point where we'll start reopening businesses and gradually letting people back out into the world. And if outbreaks still don't happen, that'll just become progressively more until finally there will be a day when we're back to, I don't want to say normal, because I don't think we're going to go back to the same normal we saw previously. It'll be some form of normal. People just need to hang tight. We'll get there.
That sounds somewhat comforting. Almost very comforting from the
we're getting there
that we're in right now.
That's very comforting. But remember, we're not going to get there from the vaccine alone. Vaccine is a really important tool, which we've talked about a lot, but everything else also matters because people can still spread this, until they've gotten vaccinated. And we also still need to learn how much the vaccine will prevent asymptomatic transmission. So the vaccine itself is going to prevent, we know the vaccine prevents symptomatic infection, but scientists are still waiting to release data about how much it prevents people from actually passing around, asymptomatic infections as well. I know that sounds confusing, but that's why after you get a shot, you still need to wear a mask.
Keep the mask on.
Keep the mask on.
Thank you so much. This was awesome. You are super cool, and thank you for all the work that you're doing in spreading this information that is not misinformation, not the disinformation, the good, the real stuff, the truth. We need it. So thank you. And
thank you, sir.
We will see you on Instagram.
Thank you for being a megaphone for truth, Malik. I appreciate you.
My day's made. All right. Thank you. Bye, everyone.